Okay, now I'm going to do the 2008 Form B question number 2. And this one, the calculator is permitted. So it says for a time of t is greater than 0 hours, the r of t is equal to 120 times 1 minus e to the negative 10 t squared. I represent the speed in kilometers per hour, which I got one straight with. So the number of liters of gasoline used for the car to travel x kilometers is modeled by g of x equals 0.05x times 1 minus e to the negative x to 2. Okay, question A says, how many kilometers does the car travel during the first 2 hours? Okay, when a lot of people see that, they just think, okay, well, I'm just going to plug in 2 hours into my speed, and I'm just going to have R of 2, and that's going to be it. It's not actually what you're doing. You're saying that it's traveled a certain amount in the first second, in the second second, in the third second. So it's an integration problem. So you're summing up all the time from 0 to 2 hours of R of t dt. Since RT was in kilometers per hour, we talked about this before, kilometers per hour times hours, that is going to give you kilometers at the end. Very visual. I would write it in this form first. You definitely make it a point for having the setup correct. If you write it like this, and you leave something off, you get the question wrong on the test. So if you left off like the negative, from the negative 10, you get that whole point wrong. So definitely write it in the simplest way first. Now, to make things even easier, I put this in for y1 already into my calculator, and I put this in for y2 in my calculator. Since it's a calculator problem, that's probably going to save you a lot of time. Okay, so when I'm integrating, the easiest thing to do is use your finite integration. So I plug in f and n. Since it's already entered my y1, other variables, choose your function y, and then choose y1, go from x, go from 0 to 2. And when you do that, you get an answer of 206.370. Always write your units. Your units are kilometers. Sometimes you get a point just adding the correct units. Okay, part B. Says find the rate of change with respect to time and the number of liters of gasoline used for the car went to just 2 hours. So whenever you see with respect to time, we're finding the rate of change, the number of liters of gasoline. So that's our G of x with respect to time. So I'm finding dg over dt. Okay. It's kind of like our related rates problem study. So dg over dt is going to be, everything's going to be in terms of t. So I'm going to do the product rule. So 0.05x times the derivative of the second part, so 1 minus e to the negative x over 2, times negative 1/2, because the chain rule. And then I took the derivative of x, which has to be in terms of t, so dx over dt, plus the first part, the derivative, so 0.05 times dx over dt, times the second part. Okay, we're finding it when t is equal to 2 hours. Okay, x is in kilometers. Okay, so since x is in kilometers, that was actually our answer from number 1. So we're finding when time is 2 hours. So we just found how many kilometers it travels during the first 2 hours. So that answer is still in my calculator. So I'm going to actually store that as, let's just store it as A. And then I'm going to write myself a note on the test. So store it as A. So if I have to use that more than once, it's in my calculator. So I don't have to come up with it again. So that's going to be your x value. We're going to plug in A for all of those. So x is in kilometers. Now dx over dt, that's kilometers per hour. So let's see, we talk about kilometers per hour. Kilometers per hour we talked about with RT. So that's your rate. So dx over dt is actually RT. So we're finding it at that particular x value. So we're finding R of 2. So it's been 2 hours. So we're plugging in R of 2 for each place. Now R of 2, I don't know off the top of my head, but I have that in for my Y2, from my Y1. So let's go to table and plug in 2. So Y1 is equal to 120. Okay, so let's plug in everything we know. So dg over dt is equal to, let's take it up, 0.05 times A, 1 minus E, as I was computing, I realized I had a very, very tiny mistake, which didn't make my answer make much sense. So I checked my derivative. So I did first times derivative of the second. So the derivative of 1 minus e to the negative x over 2. There is no 1 there. So that should just be negative e to the negative x over 2. All right, so that makes my answer look a lot nicer. So I got 6. Not nice and even, and you always want to think about the units. So G was in liters of gasoline, time was in hours, so it's liters per hour. Okay. Let's see. So how many liters of gasoline have been used by the car when it reaches a speed of 80 kilometers per hour? First of all, we need to find that time when it reaches a speed of 80 kilometers per hour. So I need 80 equals the rate of t. So 80 equals 1 minus e to the negative 10 t squared. You don't need to write that because I never find y1. So I'm finding when y1 is good. So let's isolate y1. So we'll make that fit. And we're going to find when the value is equal to 80. So you might want to put y3 equals 80. And we're going to find where they intersect. And that will be the easiest way. And adjust your window, just make sure that your maximum definitely goes up past 80, so make it maybe 100. And your X max, 10 should be fine, so. Oh, it's much smaller than 10, so let's see. Make the window 3. Yeah, 3. Maybe 10 to 3. Still really close. Maybe I think my window -2 to 2. And then it looks pretty good. Okay, it's crossing the line y equals 80. So I'm going to find the intersect. So trace along the first curve and get to where you think it is. Trace along the second curve and get where you think it is. Hit enter. Okay, I got my intersect is at t equals 0.33145. I'm going to store that. So hit second quit, and that takes you back to your normal screen, and hit enter. And, hit X. So go to X and hit enter. That gives you that value. Let's store that as B. Just in case we have to use it. And then write yourself a note so you know you store it as B. All right, that's in hours, it's time. We need to find how far it's gone in that amount of time. Before we can figure out how many gallons of gas it's used. So in that amount of time, you do 0 to B, and I'll just write B since I wrote myself I've stored it as B, of the rate, RT/dt. Let's maybe do how far it traveled in that amount of time. So RT is my Y1, so I'm just going to do math 9, so finite integration of Y1, so variables, Y variables function, Y1. X goes from 0 to alpha B. When I do that, I get 10.7940965. Store this as C. I don't know when we're going to use anything. All right, so that is the distance that you traveled. That's the number of kilometers. So the last question says, how many liters of gas have you used when it traveled that far? So X was in kilometers. So that allows us to plug in to my G of X. So I'm finding G of that value, G of C. So when I plug in C into my G function, which is stored as 2, so I just go to table and plug in. I don't know if you can plug in alpha C. You can just plug in alpha C into your table, and it's stored as my Y2, so it's 0.537, 2599, etc. So we only need 3 decimal places, and that's the number of liters. So liters capacity. Okay, so that's the end of this question. So let's talk about points really quickly. For part A, we got 1 point for setting the right integral, so remember, keep it abbreviated. 1 point for the answer. For B, we got 1 point for using the chain rule. So we use the chain rule here. Oh, we got 2 points for chain rule. Then we got 1 point for our answer with units. So we had to have units for that correct. We got 1 point for our equation RT equals 80. Notice I just wrote it very simply there. You didn't actually need the second part here, so you can just cross it out if you want, but I wouldn't cross it out in your AP test. 2 points for your distance integral, so this point, and 1 point for your answer. So those are the 9 points that you could have gotten on this